Hello students, today we are going to see the last topic, that is curl of a vector. Always curl of a vector is a vector only. Divergence of a vector is a scalar. Already we have seen in the last class. So what we got? We have seen one numerical also. Divergence, we got a scalar value. Now we are going to see a curl of a vector. What is the key point in the curl of a vector? What a curl of a vector, what it provides? It gives the information about angular momentum of your vector. So curl provides, here the key point is rotating or angular momentum of a vector is given by curl of a vector. So if you want to find the angular momentum or a rotational momentum of a vector around a point, we have to use a curl. We have to find the curl of the respective vector. So curl provides the measure of the amount of rotation or angular momentum of a vector around a point. So the simple example is, let us take the water is flowing like this. Let us take the water is flowing like this. In this direction the water is flowing. The water is flowing like this. Let us consider the velocity at this point is v1. The velocity at this point is v2. In this situation, let us consider the velocity is equal. v1 is equal to v2. It is nothing but the water is flowing with a same velocity. If I place any wood here, if I place any wood over this in the water, what happens? This wood will move in the same direction. The wood will move in the same direction. Is it right or not? Yes. So if I place any wood in this water, the wood will flow in the same direction of water flow. So here the velocities are same. Let us consider second situation. So in the flow of water, there is a turn. If there is a turn to the water, then what happens? For example, there is a turn, then the water velocity we are considering. At the turn, you are going to have different velocities. Here you may have a v1 velocity, here you may have v2 velocity. Here you are going to have different velocity. Here the velocity is, let us consider this is a low velocity. Here it is some more velocity. At this point, more velocity. So for example, if I keep a wood here in this situation, when the water is taking a turn, then what happens? The wood will move in this direction. The wood will move in the same flow of water direction. So the wood also takes a turn. So this is a second case. So here at this point you are going to have less velocity of the wood, and here you are going to have more velocity of the wood. Let us take the third situation is, if the water is flowing in this direction. If the water is moving in round, if the water is flowing in this direction, for example, if the water is flowing like this, if I place any wood in this at this point, then the wood will move in the same direction. The wood also will move in the same direction. So if I want to find the angular momentum of any vector, in this situation there is an angular momentum. Here you are going to have angular momentum, but here we don't have any angular momentum. Here the velocities are same. So in this situation the curl equal to 0. So for this situation the curl equal to 0. Here you are going to have the curl is not equal to 0. In this situation also the curl is not equal to 0. So if I want to find the curl value, that is of the rotational or angular momentum of anything, we have to use around the point it is moving. So we have to use a concept of curl. If for any vector the curl is indicated with, if f is a vector, the curl is indicated with cross symbol. Del cross f is nothing but your curl of the respective vector. If curl equal to 0, the vector is said to be irrotational vector. The vector is said to be irrotational vector. The vector is said to be conservative vector. The vector is said to be conservative vector, and the vector is said to be irrotational or conservative vector. So what is the best example for irrotational or conservative vector? That is electrostatic field. Electrostatic field, it is a vector of type irrotational or conservative. For electrostatic, what will be the curl? For electrostatic field, the curl equal to 0. Remember this one. For electrostatic field, the curl equal to 0. EL is for electrostatic. EL is for electrostatic field, the curl equal to 0. Then how to find a curl of any vector? So this is the definition of curl of a vector. The component of a curl of a vector in the direction of unit vector. For example, let us consider a Cartesian coordinate system. If the water is flowing in xy direction, this is your x direction and the y direction. In the xy plane, water is flowing. Let us consider a small area in the water flow. So if the water is flowing like this, let us consider the velocity is v1. Here the velocity is v2 at this point. The velocity is v1. So in the direction of your v1, here it is in the same direction, here it is in the opposite direction. So if I want to find the curl, we have to consider the line integration. Here you have to consider line integration because it is a line. Here if I want to find around the closed path, I need to find the line integration over here. From this point to this point, I need to find line integration. From this point to this point, I need to find line integration. From this point to this point, I need to find line integration. It means that I need to find v1, and this one is in opposite to this v2. So I have to find v1 minus v2 plus, if I consider this is your v3 and this is your v4, the velocities, the v3 is in the same direction, so v3, and it is in opposite direction, minus v4. If v1 minus v2 plus v3 minus v4, if it is not equal to 0, then we can say that there is a significant curl. We can say that there is a angular momentum of the vector. Always this angular momentum will be perpendicular to the plane. Always the angular momentum follows right hand thumb rule. The angular momentum of any vector will follow right hand thumb rule. According to the right hand thumb rule, so if I consider the water flow in this direction, if I place any object here, the object will be, it takes the rotation in the perpendicular to this plane, or unit normal to this plane is, what will be the unit normal to this plane? For xy plane, the unit normal will be z. If I consider yz plane, the unit normal will be x. If I consider xz plane, the unit normal will be y. It means that we have to consider the rotation will be, the direction of rotation will be in the direction of unit normal to the plane. So the component of a curl of a vector, in the direction of unit normal, that is unit normal is indicated with some an is nothing but unit normal vector. It is the ratio of line integration of the vector around the closed contour. Around the closed contour, we have to consider line integration, and it is the ratio of line integration of the vector around the closed contour to the area enclosed by the closed contour, which tends to 0. So whatever the statement here they have given, it's depicted as with the equation. So this is the curl of any vector. So curl of any vector is obtained by line integration. This is nothing but your closed line integration. Already we have seen line integration, surface integration, and volume integration. In the divergence, we have considered surface integration. We have considered your surface integration and divided with your volume. So for curl, we have to consider line integration and divide with your the surface, that is our differential surface. It means that what we have to do, practically what we have to do, We have to find line integration at this point, 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 and we have to consider 4 line integrations, and we have to divide that line integration with the surface or with the differential surface. What will the differential surface? So this is if I consider this is your length and this is your breadth. If you multiply this length and breadth, you are going to get a differential surface. That we are going to see now. So how to find this line integration for and surface integration for your curl. So for all these things, we are going to consider curvilinear coordinate system. For that, let us consider a vector. Let us consider a vector f is equal to. Let us consider a vector f is equal to, which is defined as f1 in the direction of your a1 and f2 which is defined in the direction of your a2 and f3 which is defined in the direction of your a3. So this is your one vector we are considering, that is which is defined. It is a component in the direction of your a1, it is a component in the direction of a2, it is a component in the direction of a3. Let us consider a curvilinear coordinate system. By using the curvilinear coordinate system, we are going to get a generalized form, and with the generalized form we are going to get your a curl in the Cartesian coordinate system and curl in the cylindrical coordinate system, curl in the spherical coordinate system. Let us consider this is your u1, u2, u3. So f is the one vector which is having the magnitude f1 in the direction of u1, f2 in the direction of u2 and f3 in the direction of your u3. This is your magnitude and this is your unit vector. Let us consider one. So here we have considered one cube. So while discussing some differential surface and differential length, so this is your differential length in the direction of your u1. This is the differential length in the direction of u2. This is the differential length in the direction of your u3. So this differential length. So if I consider this is the differential length in the direction of your u2. This is the differential length in the direction of your u1. This is the differential length in the direction of your u3. That is nothing but it is parallel to your u3. So this will be parallel to this u1. This will be parallel to u2. So here we can write. So this is nothing but I can write here. So this is nothing but your h2 du2 or dou u2, and I can write this as h1 du1, and I can write this as a h3 du3, h3 and du3. Let us write our point sum. O point, this is a O point, this is a point of A, and this is a point of B, and this is a point of C, and let us define this is a point of G, this is a point of F, and this is a point of E, and this is a point of D. So here you are having 6 surfaces, that is your O, A, B, C. This is one surface. To this surface, exact opposite surface is G, F, E, D. Next, one more surface. Is O, A, F, G, O. This is your bottom surface, and top surface is C, B, E, D, C. Next, one more surface O, C, D, G, O. Next, one more surface opposite to it A, B, E, F, A. So totally we are having 6 surfaces. Let us consider this surface O, A, B, C, O. It means nothing but we are considering this one. Let us highlight it with another color. I am considering this one O, A, B, C, O. I am considering this surface. So for this surface, now tell me this surface is defined between U3 and U2. Got my point? O, A, B, C, O, it is a surface which is defined, which is a plane which is defined in U3 and U2. For this surface, what will be the normal or what will be the perpendicular? U1 is perpendicular. So if I place anything over here, so the direction of the angular momentum of that will be in the direction of your U1 according to the curl concept. For example, if I consider one more, let us consider this one. Let us consider, if I consider O, F, A, O, A. So if I consider this is a surface. This is a surface which is defined in U1 and U2. For this surface, what will be the counter or what will be the normal? U3 will be the normal. Next, let us consider one more. Let us consider for O, C, D, G, O. For this surface is defined between U1 and U3. This surface is defined between U1 and U3. U2 is opposite or U2 is normal to this surface. Let us consider OABC. So this one is, let us consider this one is first one opposite, and this one is second surface, and let us consider this is your third surface. So we have to consider these three surfaces are to these three planes. We have to consider the line integration or your curl. Let us consider for line integration. So according to the curl concept, what you have to find? The line integration. The line integration becomes f dot dl. F dot dl is equal to, we have to find from O, A, B, C, O, the line integration f dot dl. This f dot dl becomes from O to A. From O to A we have to find, from O to A line integration, plus from A to B line integration we have to consider, from A to B. From B to C line integration we have to find, from B point to C point, and from C to A line integration we have to find. From O to A, according to the line integration, what you have from O to A, the line integration is nothing but your f dot dl. F dot is nothing but, so in this point, so on U2, what will be the factor? F2. So for O to A, let us define for O to A f dot dl. O to A f dot dl is equal to, the line integration is equal to, so on O to A, U2 is defined. So what will be the factor? F2. So F2, that will be F2, and the differential length is H2 du2. So H2 du2. So this is your line integration from O to A. And from A to B. So if it is of this A to B is nothing but it is exactly parallel to your O to C. But what is the difference? Same length you are going to have for O to C, for A to B you are going to have same length, but this O to C, this line is starting from origin, but this line is starting from the point A. It is nothing but, so this is a O to C, and here you are having one more line, that is your A to B. So this line and this line is having same length, but what is the difference? So this point, this is a line which is originating from, this is starting from origin, but this is starting from A. So there is a differential length. So this length we have to consider for A to B. So the starting points are different. So that also we have to consider. So for A to B, f dot dl is equal to f dot dl. So what will be the length of this one, which is equal to C1. So what is the O to C? O to C is nothing but F3. In the direction of U3, F3 is defined. So F3, and so what is the differential length? H3 du3. H3 du3. But it is not this A to B is nothing but it is started from A. So we have to consider this differential length also. the differential length is obtained by dou by dou u2, because in the direction of your u2 you have to consider. So dou by dou u2 f3 h3 du3 f3 h3 du3, and you have to do with respect to your differentiation with respect to u2. So the third one is from B to C. From B to C. So from B to C. So B to C is exactly parallel to your O to A, but it is in the opposite direction. So here we have to consider minus F2 H2 du2 minus F2 H2 du2, because it is a direction of this one is here, the direction will be. So but B to C is we have considered from B to C, so the direction will be opposite. So and it is started from, it is not from the origin. So here we have to consider plus dou by, so in the direction, in this direction we have to consider, so dou by dou u3 f2 h2 du2 f2 h2 du2, because this O to A, this line is started from origin, but this line is started from this point, from C it is started. So there is a differential length. That differential length is obtained by dou u3, because it is actually it is started from this O to A is started from here, but instead of starting from this B to C line, it is started from this point. On the u3 it is started from C. So this difference also we have to consider, that is obtained by dou u3 f2 h2, this component f2 h2 du2 into du3. The next one is from C to O. From C to O. From C to O f dot dl. From C to O f dot dl. From C to O f dot dl, if you consider from C to O f dot dl, the C to O f dot dl becomes your C to O f dot dl. So it is normal one. From O to C, what will be the length? So this is your from O to C h3 du3. But we are considering from C to O, that becomes your minus f3 h3 dou u3. So if you add this all things like O to A, 4 integrations, if you add these 4 integrations, so finally you are going to get, so here you are going to get some cancellations also, like f2 h2 du2 plus f3 h3 du3 plus dou by dou u2 f3 h3 dou u3 dou u2 minus f2 h2 dou u2 plus dou by dou u3 f2 h2 dou u2. Just I am adding all 4 integrations. Dou u3 minus f3 h3 dou u3. So f2, this one gets cancelled. So finally you are going to get del cross f is equal to, that is your del cross f is equal to line integration of f dot dl. Only we have considered one plane only to this one plane. Here we are going to get dou by dou u2, dou by dou u2, f3 h3, f3 h3, dou u2 dou u3. So we can write separately. Here you are having dou u2 dou u3, here you are having dou u2 dou u3. So we can write it as a plus, sorry, this is a totally, it is a minus for all these things. So minus dou by dou u3 f2 h2 f2 h2. So this dou u2 dou u3 dou u2 dou u3 separately, like commonly I am writing dou u2 dou u3 dou u2 dou u3, but according to the curl, so what will be the, so limit delta s tends to 0 and divided with your delta s, that is nothing but differential surface. The differential surface becomes, the differential surface of this one we have considered OABC. For OABC, the differential surface becomes, for OABC low, in OABC, so what is the, so this is a one coordinate or one line, that is your h2 du2, and the length of this one is h3 du3. So if you multiply, so this is your h3 du3, this is your h2 du2, and this will be h2 du2, this will be h3 du3. So what will be the area? Area is equal to h3 du3 multiplied with your h2 du2. Just multiply these two. Just substitute over here. So divided by h2 du2 h3 du3. Here you are having du2 du3. Here you are having du2 du3. So finally you are going to get 1 by h2 h3 dou by dou u2 f3 h3 minus dou by dou u3 f2 h2 f2 h2. So here we can write del cross f is equal to, that is your curl of a vector is equal to, only we have considered one plane, so 1 by h2 h3, 1 by h2 h3 dou by dou u2 f3 h3 minus dou by dou u3 f2 h2, dou by dou u2 f2 h2. So remaining thing will continue in the next class. So up to this, just practice this one.